Hi there. In this video I'll explain a bit more on what I wrote in this post. So basically I made some changes to the visualization for flowcharts using the ELK layout. And I'll just demonstrate what I aimed for. So basically when we're not using ELK, and we have subgraphs that are pretty isolated, so none of the nodes are connected outside of their subgraph. It's possible to maintain the direction. On the contrary, in this one, the node is connected, or better to say this one, it's connected to this node over here. So therefore the direction will also be inherited from the parent subgraph, in this case 1. But basically, so this behavior, although it has its limitations, is still good, except that it's not working in ELK currently. So that's what you see over here. We're using ELK, and you see that the left to right direction is inherited to all the subgraphs. So, and I made a change to prevent this behavior from happening, and this can be visualized over here. So now it's using ELK, as you can see by the colors, yet it's maintaining the direction in the subgraphs. And what I did was basically use the guidance from this page over here. So basically it explains that the behavior can be achieved by separating the children from the hierarchy. But of course, once separated, you won't be able to connect the nodes. So this is a setting that you can then use. But only if the nodes are isolated. So I added I made some code changes to check basically whether the nodes are isolated, and then to set the direction. But let's go to the beginning first. So first off, the first change, and I think I have it in the article as well, or the post. So let's see, this line was commented, but I uncommented it, so it then picks up the direction of the subgraph and adds it to the data, and then those data characteristics are then passed along to the node database. And then I added a switch, just like it's implemented elsewhere in the code, to basically set the ELK direction according to the direction that is set in the node. Then, and then basically the rest of the code stays the same, and then I apply some post-processing to modify the JSON object so that we add an attribute to separate the children, but only if the nodes are isolated. So, and I can show over here. So in case there's a connection, there's an edge that goes beyond the borders of one of the subgraphs, you'll see, and maybe before layout, let me check here, that here the container is 4. The container is set to root, but it's also visible by looking at the parent ID of the node. So for the source and the target, the parent ID is different. So I added some code to add this attribute, and basically to look up of the node what the parent is, and that will give you the subgraph. And if the two are different, then the edge goes beyond the boundaries of the subgraph that a certain node belongs to. And if that's the case, and that's, let's say here for 1, let me see. Oh, it's probably this one. So basically then the layout options, we already set it in the code to set the direction, but now we've not added the separate children, because this is something we only do whenever the nodes are isolated. So in the code, there I added a couple of functions, of course with the help of ChatGPT. First, to identify which subgraphs are lowest level subgraphs. So that's the case whenever the children belonging to the subgraph, the nodes, don't have any children themselves. In that case, we set an attribute that it's the lowest level to true. And then for those, we iterate those, and then we check for all the belonging nodes whether they have any edge or edge source or parent node that has a different parent than the subgraph that we're evaluating this for. And if it's different, we don't add separate children, but if it's all the same, then we can conclude that the nodes are basically isolated, and then we add the layout option separate children. And then we basically get this behavior. So I'll just await your comments to see if we should make a pull request out of this one. I think the nice part of this implementation is that it's not very intrusive, so it's just post-processing the graph that has already been created and modifying it. And I think the reason for doing so is because all the edges are stored on root level and not really nested inside the subgraphs, which would make things perhaps a bit more easy. Or less necessary to do it as a post-processing action. But I'm happy to await your responses. Bye-bye.